Alright, so this is going to be a video on how to create the gliding mechanics similar to Batman Arkham Knight. So the general idea is that you would be moving with a base speed, and now you can perform two actions over here. You can either dive to lower your height but actually increase your speed and momentum, and the second is rising, in which you can increase your height or altitude but you would be losing some of your speed that you gained by diving. And all of this would be balanced by something called a rise meter. Yes, that's the general gist. Now we can go over to Godot and create two scenes. One of them would be the world scene and the other one would be the player scene. Make sure that you create the player scene and extend it from the character body 3D. In the main scene, that is the world scene, what you can do is add a CSG combiner. Inside that, add two CSG boxes and place these boxes inside each other, and the one that is on the inside, you can change its operation mode to subtraction so that it gives you this nice looking playground thing that you can test your level inside. Next up, we would go to the player scene. Here, before doing anything or adding anything, I want to just make sure this is my forward direction, which is the positive Z axis, and everything that I would be adding underneath this node, I would make sure that it points in this direction so that programming becomes a little easier for me in terms of directional vectors and stuff. Okay, so the first thing that I would add is a CSG polygon. Now instead of adding a polygon, you can actually bring in your own model that you want to use, but right now, just for the sake of it, I'm using a CSG polygon. I shape it as a triangle so I know what is the head and tail of my character. After positioning it, I nest it under a node 3D and call it mesh. This would be the mesh container. The reason why I make a mesh container is because when I would be changing the orientation of this mesh for leaning from side to side, I don't want to mess around with the original rotation of the mesh that I imported, but I would rather control it using a mesh container. Next up, you can add collision shape and camera to the scene. In my current game, I do not use the camera inside this scene itself, but I use an external camera that is like a third-person camera, which makes things look a little bit more smoother. Alright, with the scenes set up, you can create a new GD script and attach it to the player. You can call it player movement, and we can head over to the programming part of this video. Before moving to the code part, I want to clarify what would be my roll pitch in yaw. The roll would be the z-axis. My pitch would be the x-axis on which the player can tilt up and down. The yaw would be my y-axis on which the player can pivot from left to right. So moving on to the code, in here what I do is break down the problem in four parts. One of them would be handling input, then handling the physics, the rotation and the animation. For my variables, you can see some of them are self-explanatory. The other ones I will go on and explain. The acceleration is the rate of change of speed when you either rise or dive. The max pitch angle is the angle by which you would be able to tilt your player on the x-axis, that is on the pitch axis. Then yaw angle is the amount of angle that you would pivot the character by per second, or I would say per physics tick. For the mesh container is the container that we created earlier. The forward variable would be used to store the forward direction. The pitch input, yaw input, and the yaw, the earlier two are inputs that I would be using for calculating yaw and then applying it to the player. I will explain this in the later part of the code. Between is the node which handles the animation for this video. Rise meter is the crux. This fills in when we are diving and it gets consumed when we are rising. The accelerated speed is another calculated value that I use to add it to the current speed so that we can emulate the effect of going faster and slower when we are diving or rising. In the ready function, you can assign the minimum speed to the current speed. This would work as the base speed for our player. In the physics process, you can order these functions. Going on to the handle input, I have used the input.getAxis method. What this does is takes two inputs in the opposite direction, like up and down and left and right, and returns either -1 or 1 depending upon the input that you've given. The next function is handling the physics, but before moving to anything, I will want you to focus on this part. We check if the pitch input is non-zero. If it is non-zero, we can start changing the current speed to accelerated speed. If no input is being given, we slowly bring the current speed to the minimum speed, which we use as the base speed. In the end, we clamp the current speed from minimum speed to maximum speed so that it stays within the range. If you're wondering how accelerated speed gets calculated, it's here. We take the pitch input, that could be either -1 or 1, and then we multiply it with acceleration. This amount gets added to the current speed, and we make sure it's always positive, so we wrap it in the absolute method. This handles the filling up and consumption of the rise meter. In the end, we clamp the rise meter from 0 to 10. Towards the end, we assign the current speed multiplied by the forward direction, so that it's always in the forward direction of our player. We assign this to the velocity, and the y component of the velocity would always be dragged down by gravity, so that's what we do in the next line. Next up is rotation. This is solely used for pivoting. It takes the yaw and it keeps on adding yaw input to it as long as we keep the key pressed. If there is no input for yaw, it lowers back to 0, and in the end it clamps itself from minus yaw angle to positive yaw angle. This is the part which actually puts things back together. So we create a tween node. If it's already created, we kill the tween node and create it again. We call the set parallel function and pass through as a parameter. After we've done that, first one is for the mesh container. This actually tells the player model on the z-axis, which is similar to rolling, and I limit it to 45 degrees. The far right number shows how long it would take for this animation to execute, which is like 0.5 seconds for now. The next two animations is for the character body 3D itself. We have pitch input that is multiplied by maximum pitch angle. This is for rotating the player model. And similarly, the other one is used for yaw, that is pivoting around the y-axis. So this is the whole script if you want to take a look at it in one go. Now we come back to the world scene. I have created a few cylinders here to make it a little bit more interesting and it doesn't look completely pale and dull. We can add a created player to this scene and see how it runs.